Hi folks, welcome back. We're going to chat about numbers 15 and 16 in Unit 3-1 about impulse and momentum. So 15 is about a rifle that fires a bullet, all right? And the weight of the rifle is given. You can use that to find the mass, and the mass of the bullet is given. And it says that the rifle fires the bullet at a certain speed. Mine says 220 meters per second, but yours probably says something different. So to attack this by methods of impulse and momentum, right? And just like every other problem about impulse and momentum, okay, you start with an impulse momentum diagram. So our first picture right here, 1, is going to be before the bullet's fired, like an instant before the dude pulls the trigger. I apologize for my super crummy rifle. I labeled it so that you knew what it would be, okay? There's no momentum in this picture. Nothing's happening yet. Okay, now our impulse picture. Right, this is what's happening between my pictures 1 and 2. Now, it doesn't say anything about anybody holding onto the rifle or anything like that. It's really, this question is really about the interaction between the bullet and the rifle. The bullet gets forced in this direction, right? So there's a massive impulse in F delta T on the bullet. But by Newton's third law, that same force acts back on the rifle. And the net impulse is 0 if we define our system as the rifle and the bullet. And then here's our picture 2. And the bullet has a momentum, mass of the bullet, velocity bullet, picture 2. The rifle has a momentum, mass of the rifle, velocity of the rifle, picture 2. And now use your pictures to write an impulse momentum equation, right? You've got no momentum plus no impulse, right? Because the net impulse in that picture is 0. And then equals your final momentum. But keep in mind your final momentum has 2 terms, one to the right and one to the left. So there's a very simple, easy equation you can write out for number 15 there that will relate all the 2 masses and the 2 objects. All right. Let's chat about 16. Looks like there's a little more going on in 16. Let's see. A 68 kilogram person throws a snowball forward with a speed of 33.5 meters per second. A second person catches that snowball. Both people are on skates. Okay. All right, so 2 people on skates, huh? Well, so I'm just going to do my super quick picture here. Here's my 2 people on skates, okay? I like to use different letters for different objects here. So I'm going to call this person A, right? So we got a mass A and a mass B. Person throws this ball. So let's talk about this here. This system starts with no momentum. Let's call this picture 1. Person throws the ball. So right afterwards, we got the ball moving to the right. This person, if they're on skates, it was a perfectly frictionless surface, would have some sort of recoil speed. Let's say this is picture 2. And you can write a momentum equation for the ball and the person. Let's call this maybe mass. We'll use little b for ball and velocity of B, picture 2, right? Mass of A, velocity A, picture 2. So you have no momentum in this picture equals the net momentum in this picture because there's no net impulse on the system. That'll allow you to write a nice, easy equation between the 2. All right, now this ball, it's heading over towards this person here. Let's call this picture 3. Ball's moving to the right. It has a momentum, M, mass ball, velocity ball, picture 3. This person, I believe, not moving, so they get no momentum. Oh. I gotta go back. I'm sorry. I read this thing and I just realized that this person was moving when they threw the ball. That's going to complicate things just a tad. So, all right, my apologies for that. We're going to get rid of this. Okay, so we have a person on skates, mass A, with a ball in their hand, moving to the right at some speed. So they've got a momentum, mass A, VA1. Now my second picture is going to be the same person, but they have now thrown the ball at some velocity. So for now, we're just going to ignore the second person. This is the same person. So what's going to happen is the momentum of that person is going to drop a little bit. So we're going to have an MAVA2 and now a mass of the ball, velocity ball, picture 2. Okay. Now write a momentum equation equating this momentum vector to the sum of these two. And I'm positive you'll be able to solve for something. Now that second person was at rest. So I'm going to put that second person over here. Sorry about the crummy picture. And we've got this ball coming at them. Mass ball, velocity ball, picture 2. Person is going to catch that ball. Oh boy, crummy picture, but now they're recoiling. And we have a momentum equal to mass of person B times velocity of person B, and this is now my third picture. So now you can write a momentum equation now between these two pictures. The momentum here equals the momentum here. So, all right, sorry about that. That got a little bit off topic, but that should be enough to get you through 16. Enjoy.